NASA's been around for over 60 years, exploring space and making some mind-blowing discoveries about our universe. They've revealed tons of unknown facts about our world and way beyond, from planets to galaxies practically at the edge of what we can even see. But here's the thing, one of their newest revelations is kind of scary. It turns out that our own sun, the giant star that makes life possible, could actually destroy the whole Earth. NASA's latest findings suggest that this could happen as early as 2025. Yes, you heard it right. And today we'll dive into this claim and answer, will the sun destroy the Earth in 2025? So, here we go. The solar probe. So, let's start from the start. Basically, the sun is this huge ball of fiery energy, and it's pretty much the reason life on Earth even exists. Scientists at NASA have always been obsessed with this star, which makes total sense. I mean, it's over 4.6 billion years old, radiates all this crazy light and heat, and it's powered by nuclear reactions in its core. Plus, it's freaking gigantic, way bigger than Earth. Since like 1958 at least, NASA's been dying to get a closer look at the sun to better understand all that energy swirling around it. But these kinds of space projects are super expensive. Finally, in 2009, it happened. The solar probe mission got the green light and got some serious cash. They started building this $1.5 billion spacecraft, originally called the Solar Probe Plus. It was designed and built by this brainiac crew at the Johns Hopkins University Applied Physics Laboratory. They finished it in 2017 and renamed it the Parker Solar Probe after this awesome astrophysicist, Eugene Parker, who actually figured out some important stuff about solar wind. He's a legend in space science, and he was still alive when they named it after him, which is super rare for NASA. The start of the mission. On August 12, 2018, the Parker Solar Probe blasted off on this epic mission to get closer to the sun than anything ever made by humans. This spacecraft is on a wild ride, flying right into the sun's outer corona. It's basically like the spacecraft has a giant heat shield, protecting it from getting totally fried by the intense solar radiation. The whole point of the Parker probe is for scientists to learn more about the sun's corona, all those swirling magnetic fields, how the solar wind gets blasted out, and how crazy particles get super energized by the sun. Think of it like the ultimate sun science experiment. Parker Solar Probe has this super cool hexagonal shield. This shield is its lifeline. It blocks out the crazy intense heat and radiation from the sun. We're talking about 475 times stronger than what we feel here on Earth. This shield is a big deal, literally. About 7.5 feet across and 4.5 inches thick. It's made of this reinforced carbon-carbon composite, which can handle temperatures of around 2,500 degrees Fahrenheit. This shield is essential because it keeps the spacecraft's instruments at a cozy 84 degrees Fahrenheit. It also has a special white coating that reflects as much of that heat as possible. Scientists at the Applied Physics Laboratory were smart to put all the spacecraft's important bits in the center of the shield's shadow, where it's protected from the direct blast of the sun. Now, here's something interesting. The probe takes around 8 minutes to send a signal to Earth and get a response back. That means this spacecraft has to be a total badass, able to react and protect itself from the sun's radiation all on its own. It has 4 light sensors that are basically its eyes, constantly watching for any glimpses of sunlight that might sneak past the edge of the shield. If those sensors spot trouble, it triggers the spacecraft to reposition itself back into the safe zone quickly. Parker Solar Probe is basically the speed demon of spacecrafts. It's the fastest object ever made by humans, and according to project scientist Nikki Fox, it's got the brains to match. This spacecraft is so smart, it practically flies itself. To power this incredible mission, it's got this awesome double set of solar panels. The Parker Solar Probe is on a wild ride. It's going to swing by Venus 7 times over 7 years, slowly getting closer and closer to the sun over 24 orbits. Because this thing needs a huge energy burst to get going, it was blasted off on a super powerful rocket called the Delta IV Heavy, with an extra boost from a special solid rocket motor. What Parker Probe saw in the space? Parker Probe has made some crazy discoveries. On November 6, 2018, it detected these weird switchbacks, unexpected flips in the sun's magnetic field. The probe's readings helped scientists finally prove that these weird waves, called Alphen waves, are a huge part of why the sun's outer layer is so incredibly hot. But it gets even better. Parker detected 1,000 freak magnetic waves in the sun's atmosphere that basically supercharged the solar wind, blasting it out at insane speeds. like 300,000 miles per hour. It also found out that some parts of the solar wind are surprisingly rough and bumpy. And there's this giant dust-free zone around the sun, 3.5 million miles wide. Just blows your mind, right? NASA scientists recently had a big reason to celebrate. Their Parker Solar Probe made a brand new discovery. It spotted a comet all on its own, which is a major deal because, up until now, the probe could only recognize comets that were already known and uploaded into its system. This little probe is getting closer and closer to the sun, and by 2025, it's expected to be zooming around at a mind-blowing 430,000 miles per hour. That's super fast, about 0.064% of the speed of light. But even with all its cool comet spotting and speedy travel, there's something even wilder to think about. Scientists have evidence that suggests the sun might be able to produce super flares. These flares could be 10 times more powerful than the Carrington Event, a massive solar storm back in 1859 that caused some serious disruptions here on Earth. Carrington Event. There's this thing called the Carrington Event, and it's kind of a big deal even though it happened over 150 years ago. You see, scientists are still freaking out about it because it was the most intense geomagnetic storm ever recorded. So imagine this, back in 1859, the Earth got smacked with a geomagnetic storm so crazy that some people probably thought it was the actual apocalypse. This whole thing, the Carrington Event, went down from September 1st to 2nd, and it wasn't just some local thing. We're talking about worldwide insane auroras, the kind they talk about in those nature documentaries. Apparently, this massive geomagnetic storm set telegraph stations on fire and knocked out communication systems for days. Scientists think the whole thing was caused by a ginormous explosion on the sun called a coronal mass ejection, slamming into Earth's magnetic field. On top of the messed up telegraph stations, the Carrington Event is also connected to an insanely bright solar flare that happened on September 1st. There's this guy named Richard Carrington and another guy named Richard Hodgson. They're British astronomers and they spot this crazy bright flash on the sun. Turns out it's the first time anyone's ever seen and recorded a solar flare. But here's the weird part. This whole Carrington Event thing happens a few months before what's called a solar maximum. Basically, the sun has this 11-year cycle where it goes from chill to super active, and that active time is the solar maximum. This is when you get lots of sunspots and the sun blasts out a bit more energy. One of the things that happen during a solar maximum is big solar storms. Solar maximum. Now, scientists can't predict exactly when a solar maximum will hit, or how strong it'll be. They just kinda know it takes an average cycle to go from one maximum to the next, and those cycles can last anywhere from 9 to 14 years. Anyway, out of all the solar storms recorded, the Carrington Event is still the most intense. Scientists think a coronal mass ejection, CME, basically a burst of energy from the sun, smacked into the Earth and caused the whole mess. That journey usually takes a few days, but this CME was supercharged. Why? Because another CME earlier kinda cleared the way, a bit like a cosmic highway. Astronomers had no idea this massive solar storm was about to hit, but luckily, two amateur astronomers happened to be in the right place at the right time. Carrington and Hodgson independently spotted the solar flare that caused the whole mess. Just before noon on September 1st, Carrington, who was checking out some sunspots, saw this crazy blast of white light on the sun's surface. Meanwhile, in a small town outside London called Redhill, Hodgson witnessed the same thing. Their reports about the solar flare were published together in the Royal Astronomical Society's journal, and their drawings of the event were even put on display at a big meeting of the society. Basically, these two guys were the unsung heroes who first documented this intense space weather event. Another twist in the storm? It turns out Carrington wasn't the only one who noticed that crazy solar flare. This Scottish scientist, Balfour Stewart, saw some weird stuff happening on his magnetic instruments at the Kew Observatory the same day. The next day, September 2nd, the instruments went totally nuts, showing a full-on geomagnetic storm kicking up. This magnetic mayhem lasted for over a week. When Carrington heard about Stewart's observations, he was like, "Whoa, I bet there's a connection here." As more reports of the 1859 event came in from around the world, an American mathematician named Elias Loomis jumped in. He gathered all the data and published it, basically confirming what Carrington and Stewart had been saying. So yeah, it's no surprise that this thing got named the Carrington Event. But one of the coolest parts of this whole story was the auroras. These light shows, also known as the Northern or Southern Lights, lit up the sky all over the world. Normally you only see this way up north or south, but the Carrington Event brought them way closer to the equator. Basically, the sun blasts out energy and stuff that messes with Earth's magnetic field, and that's what creates the auroras. Earth isn't the only place with auroras either. Most planets and even some moons have their own version of this awesome light show. Most of the time, you gotta be somewhere within the auroral zone to catch the best auroras, but if there's a massive space storm, that zone gets huge, and you might get lucky enough to see them far outside the usual areas. What if the Carrington Event happened today? We'd have massive power outages, not just for hours or days, but for years. Yeah, you heard me right. See, the thing is, unlike back in 1859, our whole lives run on electricity. From our phones to some cars, hospital equipment to how businesses even operate. It's all tied up with power. The chaos from a super solar storm in today's world? Hard to even imagine. Lives would be lost at hospitals when they go dark. Businesses would crumble, and the economy would tank fast. All because of a massive energy grid blackout. And get this, if the power was out for decades, yikes. The thought of it is terrifying. Remember that geomagnetic storm in 1989? It blacked out the entire Canadian province of Quebec in a blink. And that was small compared to a Carrington-level event. According to NASA, 6 million people were left in the dark for hours. It didn't stop there. The storm wrecked stuff in New Jersey, including a nuclear power plant. It almost took down the whole US power grid. A study back in 2013 found that a storm like the Carrington Event would cost the North American power industry over $2.6 trillion in lost money alone. And that's not even counting the rest of the damage. Radio, GPS, forget about it. These storms mess with the atmosphere and totally screws up every signal. Even our satellites aren't safe. The storms can heat up the atmosphere enough to drag them out of orbit. Hit that like button, subscribe to The Rocket, and smash that bell icon so you never miss an update. See you in the next one.